So we are on page 120. So we're on page 120. Yesterday, we talked about, or actually a couple days ago, we talked about what happens when I'm inside the bubble. What does this do? So 120, we talked about when we are in here, what does that do to my vertex? It moves it which way? Right or left? And it moves it inside the bubble. It always moves opposite the way I think. We're even going to use that today for what we're talking about. So this is right or left, opposite way I think. What does D move it? Up or down, and it moves it the way that I think. Okay, that's 2.2. That's what we all talked about. You're going to need to know that for your quiz tomorrow. That is on there 100%. Yesterday, we talked about how does A affect my graph. Well, we went here and we said, hey, especially like this one, what is that going to do to my graph? It's going to take this guy and it's going to make it super skinny because it's going to be a vertical stretch. How do I know that? Because my 4 is bigger than 1. We talked about that yesterday, yes? And again, we said, how do we picture that? We picture it's like a rubber band. And imagine if I pull up on a rubber band, it gets super skinny. Right? That's why it's a stretch from the vertical. And we said, hey, what if I push down on it? What does it do to it? It's going to make it flatter, which is what happens with these guys right here. And the further I am away from 1, the wider it's going to get. So it should look something like this because of that 1/4. Does everybody understand how I can see how this is affecting the graph? We talked about that all yesterday. Well, this would be called a vertical because it's coming from the top. It's affecting, if it's vertical, what is it really affecting? The Y values. It's really affecting the Y values, and it's going to be a vertical compression. So just to give you more of an idea of that, if I make a graph, and I'll make it a real easy one. If I say f of x equals 5x minus 2 squared plus 3. What does this do to my vertex? And actually all the points. It goes to the right too. So if I was making an x and y chart, I know that it would be 2, comma what? 3. How do we know that? This is my H and this is my K. This is going to be my vertex. Is everybody okay with that? Well, we're going to look at our parent because remember, I want to show what I mean. How does this affect my graph? Okay? What's my parent normally? That's my vertex. Remember, my parent is f of x equals x squared. Is everybody with me so far? So, if I was picking another point, I went 1 to the right, and I got 1 out for my parent function. Plug 1 in, you get 1 out. What if I go to this one? Am I going to want to put 1 in here? I want to move 1 to the right. So how would I move 1 to the right if I was at 2? What would be my next x value that I'd try? So everybody understand, to go 1 to the right, I would go 3. Well, what happens if I plug that in? 3 minus 2 is 1. 1 squared is 1. 1 times 5 is, and 5 plus 3 is, but let's look at this. When I went 1 to the right here, I went 1 to the right here, so that's the same. What happened here? I jumped up 5. What did I jump up here? Just up 1. Are you following me so far? Plugged in and chugged. Which means I just simplified. Does everybody see that connection so far? Now, we haven't made too much of a connection, but we're going to make a big one the next one we do. What would be my next x that I'd want to pick here? I try to pick 4. What would be my 1 over here? Would be 2. And 2 squared would get me to 4. So this would be 2 to the right. And what did I go from the vertex? This is always going back from the vertex. I went up 4. Does everybody see that connection? From the vertex, I went right to here. But that means I went up 4, actually. Well, let's see how that affects over here. What does this 5, how does it have an effect over here? 4. 4 minus 2 is? 2 squared is? Times 5 is? Plus 3 is? So if I went to the right 2, what? Oh, sorry, this is a 23. What did I go up, actually? This is a 3. Always going back from the what? Not going back from the 8. I'm not talking about here. I'm going back to the vertex. Does everybody see what I'm talking about? Do you see how I went up 20? How much did I go up here? 1. How much did I go up here? How much did I go up here? How much did I go up here? Do you see a connection? What's 1 times 5? What's 4 times 5? How does that y affect? Normally what I was supposed to go up was 1, 4, and then we could do the next one and it would go up a certain amount for my vertex. And how much would this go up? Would be 5 times that amount. Does that kind of make sense? Are you with me on how this 5 affects this graph? Do you see how it's going to shoot up higher, faster? It was only supposed to go up 4, and it ended up going up 20. Right? It's going over only 1. It's going only over 1 still, but going way up there. Which is going to make my graph very skinny. You with me on that? That is called a vertical stretch. And how do we know that? It's outside the bubble, and it's bigger than 1. How are we doing? Now let me talk about something real quick too, because I want to show you. If I wanted to mirror this, let's say this, because I went to the right, so that only gets me the right side of my problem. How would I get the left side? Instead of going 1 to the right, I'd go 1 to the, and that when I'm referring to that, I'm always talking about the vertex. So if I go 1 to the left of 2, what number am I actually at? I'm actually at 1. Think about it. If I'm on a number line and I'm at 2, if I go to the right one, I'm at 3. If I go to the left one, I'm at, so does everybody see, right here, I went right 1. Well, right here, I went left 1. So this point right here should be mirrored by this, which means what do I know about this y? 1 should be the same y as this. It should also be in 8. That's how you mirror it, remember? Over to the left or right one, up to the same y. Over to the left one, up to that same y. If I went 2 to the left, where would I be at? 2 to the left from 2. 1, 2. My x would be 0. Does everybody see that? What would be my y that would mirror that? This is a 23. You see how I'm getting those ordered pairs real quick? That's that mirror idea that I was talking about. So if anyone ever asks you to graph this, the book tries to teach you to use the translations to come up with the ordered pairs and always go back to the parent. I'm not teaching you that. I'm teaching you that you should know that this thing should look a lot skinnier. But if I ask you to graph it, just put points in there and then mirror it. That will never ever get you the wrong answer. The only way you do that is if you, when you plug in, you make a silly mistake. Does everybody understand what I'm talking about here? So here's the way I would like you to graph something. Let's say we give this. If I ask you to graph f of x, equals 2x plus 3 squared minus 1. If I ask you to graph it, the first thing I want you to think is, what do I know about this whole graph? What is this going to move it? Left, 3. And what is this going to do? Down, 1. So before I even graph this, I know what quadrant this is going to be in. I know it's going to be left and down, which puts me in this quadrant. Are you with me on that? So I can think ahead. So when I make my graph, I know that I'm going to make it look something like this. Then I know that it's going to be a stretch of 2. So I know that if my normal graph looks like this, it's going to be skinnier. I also know that this graph should be facing up because this is a positive. Do you see how I know all this stuff before I even start graphing it? And actually, if I was doing this, I would rewrite this and I go, you know what? I didn't draw that very well. I'm going to be left and down, but I'm only going down how many? 1, and the rest of the graph is going to be going up. Are you with me on why I changed that? You see how if you know what this should look like. Now, when I graph it, just keep that in mind, but what should I make? A T-chart. It will never fail you. What's the first point I always find, no matter what form they give me? The vertex. Right, they gave me vertex form. So, my vertex is going to be -3, -1. 1, 2, 3, 1. And now I make my T-chart, which I've told you about. What would be my next point? -2. What would be my next point? -1. I plug those into my x's and I figure out my y's. I'm not going to do this whole problem. And then that would give me points over here on this side, something like that. Then I'd go over and up to get to that point, so I'd go back and up to get to that other point. I mirrored it. Does everybody understand kind of the process of how I would graph this actually? Now, once I got my points, I would go, did it move left 3 and down 1? Yes, it did. Was it skinnier than a normal graph? Well, yes, it was. Was it facing up when I graphed it? Yes. Then all the things that I thought in the beginning came true when I actually graphed it. Do you get how this is useful about knowing what this stuff does? So today we are talking about 2-4. It's our next part. It's gotta be soon. All right, so these are talking about today horizontal dilations, which are still going to be horizontal stretch and horizontal compressions. But let's think about our rubber band first before we get started with this. What happens if I have a rubber band? What does it mean to be horizontal? So wait, remember the last one we were talking about was a vertical. Where did my pressure come from? The top, right? Where's my pressure going to come from if it's a horizontal? So let me ask you, if you were taking a rubber band and you were trying to stretch it horizontally, what would you be doing to do that? Wouldn't you be pulling this out and pulling this out? Well, what would my rubber band look like in the end? So think about this as a parabola. If this is my parent, this is my normal, and I stretch it horizontally, it gets what? So what does a horizontal stretch kind of mimic? Doesn't it look like a what kind of compression? A vertical compression. See, it's kind of hard to tell the difference between a vertical compression and a horizontal stretch because the end result looks the same. Are you with me on that? Well, let's look at what if I had a rubber band and I compress it, meaning I take my two hands and I push in the middle. I push a rubber band together what's it going to do? It's going to look more like that, which looks more like a what? A vertical stretch, so it looks like this essentially. Now it's going to look like that. So that's actually what a horizontal compression looks like. You kind of with me? Here is where a horizontal compression occurs. Where is this 1/2 located? Notice what it is inside. It's inside my parentheses. That is how you are going to know that this is not a vertical, but it is a horizontal dilation. It's going to happen inside the parentheses. Do you see the difference between the horizontal and the vertical? Are you with me? Now, here's what happens. Remember how I told you this moves what? It moves it left because you think it moves it right, but inside the parentheses, what does it do? It's the opposite. The reason I'm telling you that is, what do you think this dilation is going to be? It's going to be the opposite of what you think. What would a 1/2 normally have been? What would we have called it before today? What did I call it? Yes, just 2 minutes ago. A 1/2 I called a compression. On the outside, remember that? If it was vertical, a 1/2, if it's 0, between 0 and 1, I called it a compression. But since it's inside these parentheses, what are we going to know it as? This is going to be a horizontal stretch. So what would this graph look more like? If I was going to draw a quick picture, it would be wider than normal. Why? Because it's a horizontal stretch, it's going to pull that graph out farther. Does that make sense? Not squared here. Do you see where is that 2 occurring? Inside the parentheses. So is this going to be a horizontal or a vertical dilation? It is going to be a horizontal. It is not going to be vertical because it happens inside my bubble. And since it hit inside my bubble, it's going to be what? The opposite of what I think. Normally I would think 2 is a what? Normally I think 2 is a stretch because it's bigger than 1. But inside the bubble it does what? The opposite. So it's going to be a horizontal compression of 2. So what is this graph going to look more like? It's going to look more narrow because remember, we're going to compress it. We're pushing horizontally, means we're going to compress it. Are you with me? This thing also does something weird to the vertex. Remember how my vertical stretch and my vertical compression, did it do anything to my vertex? If I had this, what is my vertex? vertex is -1, comma, -2. Notice, this vertical stretch did not change my vertex at all. It didn't move it at all. It had no effect on the vertex. The reason I'm telling you this is because a horizontal will have an effect. It has effect on what the x value is. Remember, when I was finding my vertex, what does -1 do to this bubble? What does -1 do to this bubble? What's -1 plus 1? Makes it 0, correct? Do you see if you put a -1 in here, it makes it 0. That's what I need to do in order to find my vertex. What's the problem here? Half of you are going to say, what's your x? You're going to try -4 as your vertex. But plug it in. What's -4 and half of that? -2. What's -2 plus 4? Is it 0? So this is not going to be my vertex. -8. Now -8 times half is -4. -4 plus 4 is 0. And then I see that -2. That is my vertex. So the only thing that stinks about a horizontal is that it actually affects where your vertex is going to be. Are you kind of with me? Now, if I asked you to graph this, what would you do? Where do I know this is going to fall? It's going to move to the left. I know it's going to move left, and I know it's going to move down. And it actually moves left quite a bit. So, if I was graphing this, I know it's only going down 2, and I know it's going to be facing up because it's positive. So I know I'm barely going to be down here, and it's going to be a minimum. I know the rest of my graph is going to be going from here up. You with me on that? So that's why I know to graph it like this. Now, what have I told you to do for the rest of the points? What should you do? Plug in points. The book tries to teach you how to shift this by using all these different tricks. I'm just trying to teach you to do what? Because it'll be 10 times easier. Now, would I want to plug in -7? Yes? No? Why not? Why so? If I plug in -7, what's half of -7? Is it a pretty number? Or does it remind you of yourself? Exactly. So, what would be another number that I would want to use instead of -7? How about -6? Remember, the reason I'm saying that is on my number line, if I'm at -8, I like to move to the right. So if I move to the right, it'd be -7. Well, when I tried that, that wasn't a good number. So let's try -6. Are you with me on where I'm getting my numbers? -6. Half of -6 is -3. -3 plus 4 is 1. 1 squared is 1. There's nothing out here to multiply, so it's just 1. 1 minus 2 is... So if I go -6, 1, 2, 3, 4, 5, 6, I go down 1. Right? Now, isn't my parent function like this? 0, 0, 1, 1. Shouldn't it be over 1, up 1? What did I have to do in this one? I had to go over 2 to the right in order to get just up 1. Do you see how this is wider than what it normally is? And why does that make sense? What does this do? This is a horizontal stretch, which means it's going to pull that graph out. So everything that I've been taught is making sense down here. How could I mirror that one? If I went 2 to the right, I could go now not to the right, but 2 to the left. So I'd be at negative not 8, but 9, 10. There you see, -10. And what would be my y output for that? over 2 up 1, over 2 up 1. So it would be -1. Those two are mirrors of each other. Yes or no? What would be my next point that I would try? Would I try -5? No. Would I try -4? And I'd plug that in, figure out what my y is. And then I could mirror that point. Does everybody understand how to graph these? Okay, last thing is for your test tomorrow. This is exactly what a test is going to look like. F of x equals 2x minus 3 squared plus 7. It's going to say, do you have a horizontal shift? A horizontal shift means you are physically taking the graph and moving it left or right. That comes from right here. What do I know my horizontal shift is? Right 3. And on your test, it's going to have this, and you just write this in. It's then going to say, is there a vertical shift? Is there a vertical shift? Up 7. Is there a horizontal dilation? Where does the horizontal dilation occur? It would occur right in here. That's what we talked about today. Is there any dilation? So you would write none on your test tomorrow. And then it's going to ask for a vertical dilation. Where does that come from? Right here. And remember, this is the normal way. So since it's greater than 1, I know that this is a vertical stretch, and it's by what? 2. And that would be what your test is going to ask you for tomorrow. Does that make sense? And everybody feel comfortable with answering questions like that?